Hey everyone, welcome back to the networking series. Today, we're diving into routing protocols, the rules that determine how routers find the best path to forward data across networks. We'll explore four of the most commonly used routing protocols: RIP, OSPF, EIGRP, and BGP, and explain how they work and where they're used. By the end of this video, you'll have a solid understanding of how these protocols help keep the internet and large networks running smoothly. Let's get started. First, let's define what a routing protocol is. A routing protocol is used by routers to exchange information about networks and determine the best path for data to travel. When data moves between routers, it doesn't take a straight line. It hops from router to router, following the most efficient route based on criteria like number of hops, bandwidth, or network condition. Let's take a look at one of the oldest routing protocols, RIP, or Routing Information Protocol. RIP is a distance vector routing protocol that uses the number of hops between routers to determine the best path for data. Each router running RIP periodically sends out routing updates, sharing its routing table with neighboring routers. RIP is simple to configure but has limitations. It uses a maximum hop count of 15, meaning that if a network is more than 15 hops away, it's considered unreachable. This makes RIP unsuitable for large, complex networks. Additionally, RIP can be slow to converge, meaning that it takes longer to recover from network changes or failures. As a result, RIP is mostly used in small networks where simplicity is more important than speed or scalability. Next, let's look at OSPF, or Open Shortest Path First. OSPF is a link state routing protocol, which means it has a more advanced way of determining the best path for data. Instead of using hop count, OSPF looks at the state of the network links, such as bandwidth and congestion, to calculate the shortest path for data to travel. OSPF is much more efficient than RIP and is widely used in large enterprise networks. Routers running OSPF share information about link states with other routers in the network, allowing them to build a complete map of the network. This makes OSPF faster at adapting to network changes and better suited for large, complex networks. One of the key features of OSPF is its ability to divide networks into areas. OSPF uses a hierarchical structure with a backbone area that connects all the other areas. This structure helps reduce the amount of routing information that needs to be shared across the entire network, making it more scalable. Now on to my favorite, EIGRP, or Enhanced Interior Gateway Routing Protocol. EIGRP is a hybrid routing protocol developed by Cisco that combines features of both distance vector and link state protocols. EIGRP uses metrics like bandwidth, delay, load, and reliability to determine the best path, which makes it more flexible than RIP. It's like the Ferrari of routing. One of the advantages of EIGRP is its fast convergence time. When a network change occurs, EIGRP quickly finds a new route without flooding the network with unnecessary updates. EIGRP is easy to configure and scalable, making it popular in enterprise networks, especially those using Cisco equipment. However, it is worth noting that EIGRP is a Cisco proprietary protocol, meaning it's mainly used in networks with Cisco routers. And finally, the big dog, we have BGP, or Border Gateway Protocol. BGP is the protocol that powers the internet, allowing different networks known as autonomous systems to exchange routing information. While RIP, OSPF, and EIGRP are used within a single network, BGP is used for routing between networks. This makes BGP an exterior gateway protocol, while the others are considered interior gateway protocols. BGP is highly scalable and can handle the vast number of routers needed to make the internet work. However, BGP is also more complex to configure and requires careful management. It uses a range of metrics, including path attributes, to determine the best route for data. These attributes include AS path, the list of autonomous systems data must pass through, and next hop, the next router along the path. BGP plays a critical role in the global internet by allowing internet service providers, or ISPs, and large organizations to exchange routing information and ensure that data can flow between the different networks, regardless of geographical location. Now that we've covered the basics of these routing protocols, let's talk about when you might use each one. RIP, I would never use it. But seriously, RIP is best for small networks with simple routing needs. It's easy to set up, but not ideal for large or dynamic networks due to its limited hop count and slow convergence. RIP. OSPF is the go-to protocol for large enterprise networks that need efficient routing. Its link state nature allows it to quickly adapt to network changes and scale across large networks. EIGRP. This one's a great choice if you're using Cisco equipment and need a fast converging, flexible routing protocol. It combines the best of both distance vector and link state protocols. BGP is essential for routing between large networks like ISPs or multinational organizations. It's complex but necessary for ensuring that data can travel across the internet smoothly. Let's also touch on a few terms you might encounter when working with routing protocols. Convergence. This refers to how quickly a network can adapt to changes, like when a router goes offline. Faster convergence times mean that the network can restore connectivity more quickly after a failure. Metrics. These are the values routers use to determine the best path for data. Different protocols use different metrics, such as hop count in RIP or bandwidth and delay in EIGRP. Administrative distance. This is a value that indicates the trustworthiness of a routing protocol. If a router is running multiple routing protocols and receives routes to the same destination from different protocols, the route with the lowest administrative distance will be preferred. So to recap, RIP, OSPF, EIGRP, and BGP are four of the most commonly used routing protocols. RIP is simple but limited, while OSPF is efficient and scalable, making it ideal for large networks. EIGRP is a flexible, fast converging protocol popular in Cisco-based networks, and BGP is used for routing between networks across the internet. In the next video, we'll be covering network troubleshooting tools, where we'll dive into the essential tools you can use to identify and fix network issues. Be sure to subscribe so you don't miss it. Thank you everyone for watching. I really appreciate it. Don't forget to like, comment, and subscribe, and I'll see you all in the next video. Take care.